Hi, continuing. Sorry if the last video ended abruptly, but YouTube will only let me go up to 15 minutes. So we were about here, okay? So we had the 20 gobstoppers, okay? We partitioned them into groups of 4 here, so we think of that as dividing by 4, and then we multiply by 7. So and then notice, connecting this again to the broomsticks, okay? There's 7 quarters times as many times the 20 gobstoppers to get to 35 Smarties. Okay, and again, you can write the corresponding proportional statement. So notice this was a part-to-part comparison. We didn't know anything about totals. We knew total number of gobstoppers, but not the total number of gobstoppers and Smarties. So this one was a little bit different than the last one. And notice how this unit analysis really helps them set up the proper ratio to multiply. Okay, this is the same idea, but now you're starting with Smarties and going to gobstoppers. And now let's move on to rates and unit rates. Okay, and just to jump back, notice how here we kind of made a unit rate or a unit ratio. Okay, so when we say there's 7 Smarties to 4 gobstoppers, we could also think of this as 7 quarters of a Smartie. Is that how the singular of Smarties? I don't know. Per gobstopper. Okay. We don't really talk about this yet, but again, this is the same idea we're going to use. Lots of times students intuitively, if they have good proportional reasoning skills, they find unit rates and then multiply instead of going directly to multiplying by the appropriate ratio or rate. Okay. So but again, the idea is to get them to see this cutting, taking the copies, and then thinking of this as a multiplicative factor to get the result. So back to unit rates. Okay. So again, we're going to have them here, calories per cookie, cookies per calorie. Okay. We have them do this in both directions. Okay. And again, the reasoning to show them that the rates in this case will be reciprocals. We're also going to look at unit rates, and to start off, even though in most of the problems we're going to use decimals, here I'm always going to use fractions just so they can see that reciprocal relationship. Okay, so again, it's good to start. We want the unit rate, but just a rate in calories per cookies. So this would be 200 calories per 4 cookies. Okay, and I talk in the packet, and you want to bring this up. Notice how this is a rate, it's changing. Calories and cookies are not measuring the same type of measure. Okay, how when we look at miles per hour, miles is distance, hours is time, but suddenly we have this new unit of measure that's measuring speed. That's neither miles nor time, but a relationship between miles and time. So it's good to bring that to their attention as well. So unit rate in calories per cookie, here we'd have 50 calories per cookie. Okay, here we'd flip this just to save some time. Here we'd say there's 1/50th of a cookie per calorie. Okay, so getting them to see the 50 over 1 versus the 1 over 50, they're reciprocals of each other. Okay, same idea here, but now we're doing miles per hour. Here we have a rate in dollars per pill and pills per dollar. Okay, okay. And now here's an example for comparisons. Okay, so Callie is buying cereal, 12.2 ounce box costs $4.39, bigger box costs this. Okay, so we're going to have them find the unit rates and have them find them in both directions. So rate in ounces per dollar. Here we will use decimals, and we'll go to 4 decimal places. So where's the small box? Okay, and we have ounces. So here we have 12.2 ounces are $4.39, and we need to find the unit rate, which I don't know. Let me pause and fill this in, okay? Okay, so I filled these in. Here are the original ratios that you want them to set up, and then we found the unit rates. And notice we found these in two ways because they could find it either way, but then they have to interpret it. So do they think small is better or is large better? And of course it depends on what type of rate you have. Okay, so looking at ounces per dollar, okay, we want them to see it's better to get more ounces per dollar. Okay, so the small box is better. And I intentionally made it the small box because it's always a large box that's a bigger deal. Okay, the small box is better because it costs less dollars per ounce. Okay. Now here, looking at the unit rates in dollars per ounce, did I just write that wrong? Oh, no. Okay, sorry. I filled this in correctly, but I referred to this one when I should have referred to this one. I should probably reorder these. So this was talking about dollars per ounce, which is this. And the small box, notice the dollars per ounce is less. Okay, so the small box is better because it costs less dollars per ounce. And we can also say the small box is better because you get more ounces per dollar. Okay, so this will help them start to interpret unit rates in different ways. Okay. Now there's two problems using unit rates to solve application problems in the media lesson, and something we're going to start to do here is have them fill in tables. Okay, so again, this will get them ready. Proportional relationships, linear functions where the intercept is the origin, and just help them to get to see these patterns. Okay, so I have them use doubling and halving a lot. Okay, so Stephanie can walk 5 miles in 2 hours, used to fill in the chart. So they should start by saying, okay, here we have 2 hours and 5 miles. Okay, I also say in the video, which I should have included here, but it might have been too wordy, assume that she walks 5 miles in 2 hours at the constant steady pace, no matter how tired she is or something like that. Okay, but you might just want to mention that to them. Okay, so ways they can fill this out, they can start seeing that, well, in 4 hours she'd go 10 miles, in 6 hours she'd go 15 miles, assuming she could still walk that fast. Okay, to get to the unit rate, okay, we divide 5 by 2, so this would be 2.5, and then they can maybe start filling in these. Okay, so her unit rate, you can tell this from the table because in miles per hour, because it's saying per 1 hour, there's 1 hour. Okay, using the unit rate, how far will she walk in 8 hours? So they might just add on 5 to 15. That's one way to think of it. Okay, or they can also say 8 hours times, okay, set up the appropriate multiplicative comparison. It's 2.5 miles per 1 hour. So notice how we're using unit analysis again. The hours cancel, the miles are left over. That's 16 and 4, which is 20 miles. Okay, and then here's one that they're less likely to be able to solve just by multiplying. They'll need to use the ratio to do the 3.75. Well, they'll likely be need to do that. Okay, so the same idea. I also write the corresponding proportion, and you know how to do that. Okay, and then here we flip it to unit rate of hours per mile. Okay, so that would be hours per mile. We can flip it as 2/5 hours per mile. Okay, and again from the other rates, I don't think I talked about this. So this is 2 hours per 5 miles. And then you may want to talk about how we can think of this as dividing the top and the bottom by 5, or whatever way makes most sense to them. This is equivalent to 2/5 hours per 1 mile. Okay, so it takes 2/5 of an hour for them to go, for Stephanie to walk a mile. Okay, and then using this unit rate to solve these. So she wants to walk 20 miles. Well, it's 2 hours. Okay, I just put 5 miles down here. Okay, or you could put 2/5 hours per mile. That would probably make it messier. Okay, and then we get that would take 8 hours. Okay, and then this would be a marathon, and the same idea. Okay, just another problem. Notice here I have them use doubling. So it says blah blah blah. After 24 hours, the bucket has 8 gallons of water in it. Okay, so here they'd start 24 and 8. Okay, and then notice these are halving up here. Okay, so in half the time it would leak half the amount. In half of 12 hours it would leak 2. In half of 6 hours, 3 hours, it would leak 1. Okay, and then when we get here, we could think of it as the gallons divided by the hours, or 1/3. Okay, so they could find this by looking at the first value, and then there's more examples where they'd now use the gallons per hours to solve problems, and on the next slide they'll use hours per gallon to solve the problems. Okay, in the next video we're going to look at proportionality, and that will be it for this unit.